Good afternoon, everyone. My name is Anubhav, and I welcome you to this session on demystifying cloud security architectures. I'm part of a security business unit at Cisco. I'm a principal architect. I work closely with product management team, engineering team, and work on enhancing our products. So I've been with Cisco for more than 17 years. I have done multiple roles. I've been a TAC engineer, TME, software engineer, solution architect. When I was a solution architect, I wrote a couple of Cisco validated design guides on securing cloud infrastructure. But right now, I'm closely aligned with product management team on working on the roadmap. But since I joined Cisco, I've been doing cloud security and data center security. When I'm not working, I like to travel. I am from North Carolina, and when I travel, I take my camera with me. I try to click pictures, and these are some examples of pictures that I've clicked in the recent past. I've included my contact information as well. In case you have any question, feel free to reach out to me. If I'm not the right person to answer your question, I will connect you with the right team member who can help you with your question. I have a packed agenda for today, so I would really recommend if you are on Cisco WebEx, try to join this space, post your questions there. One of my colleague, Eric, is going to be answering those questions. If there are any questions pending at the end of the session, I will be taking those questions live, and I plan to stay for another 15, 20 minutes after the session. If you have any question, we can discuss those as well. So here is our agenda for today. I'm going to start off with a quick introduction, where I will talk about application landscape, how applications are changing, and what kind of new requirements we see from our customers and partners. Then I'll give you a quick overview of cloud security, Cisco Cloud Security, and then I will talk about security cloud control as well. Then we will deep dive into micro-segmentation, macro-segmentation, firewall as a service, and towards the end, I'll talk about AI defense, and then I'll share a few resources as well. Since this is a 90-minute session, I'm going to be showcasing a few demos as well. And that is a new demo because we have recently launched something new using which you can orchestrate your virtual firewalls in the cloud. So I'm going to showcase that as well. And I'll start with this particular slide, and I know everyone is aware of this, but I just generally start with this slide because I just want to set the stage right and talk about what kind of requirements we see from our customers. The applications are everywhere. Applications are deployed in data center, co-location facilities, campus, public cloud. We have customers who are on the journey for multi-cloud, but majority of our customers are on hybrid cloud. Once you have applications spread across, you have an increased threat landscape, and you need a solution that can give you complete visibility and control of your entire network. At the same time, majority of the use cases that we see today revolves around micro-segmentation and macro-segmentation. When you have your applications in the cloud, generally, what we see is you want to access those applications. That is your north-south use case. Traffic coming into your infrastructure or going out of your infrastructure, or your workload is talking to another workload, which is your east-west inspection use case. Then we also see a requirement where you have applications in your data center, you have applications in the cloud, and you want to have similar kind of security for all your cloud infrastructure. So that's the hybrid cloud security. And you have remote users. You want to provide access to your applications for your remote users as well. There are other use cases like distributed offices, branches. We are going to touch on those as well. If I double-click on the application deployment, initially, applications were deployed on bare metal servers. Then we saw a phase where customers were deploying applications on VMs. But more recently, we see majority of our customers are focusing on Kubernetes. So you have microservices architecture running in the cloud. But at the end of the day, networking requirement remain the same. So you need to have IP address on the application so that your application can talk to another application, or somebody can access your application from external world, or your application will access internet. And at the same time, you need to ensure that your data, your application is secure, and is it highly available or not. In most of the cases, what we have seen is when you have applications are generally deployed in autoscale. And you have network services which are not. So we need to make sure that your network and security services are deployed in such a way that it can match the speed of your application as well. If your application is scaling up, and if there is a requirement for additional throughput, we will scale our security services as well. Easy to troubleshoot, that is one of the biggest requirements from any customer we speak to. Now I'll talk a little bit about security cloud control. So security cloud control is a cloud management platform. It has a built-in AI assistant. You can write your AI prompts. It will talk to all the security services and provide you information that you have requested for. Now, we have gateways which are focused on macro segmentation. So secure firewall threat defense is available in various form factors, hardware or virtual. Multicloud defense, consider multicloud defense as a SaaS offer that orchestrates your security services in your environment. And I'll double click on all these components one by one. Deploying virtual firewall in the cloud can be a little complex because you have to understand entire cloud infrastructure. That's the reason we have invested in ensuring that multi-cloud defense can instantiate these firewalls natively in your cloud infrastructure. Once we are done with gateway, we will switch to segmentation piece. In 2024, Cisco made an acquisition of Isovalent. Isovalent is the company behind eBPF, Cilium, and Tetragon. So we are going to talk about how exactly we can use those constructs to provide security for your microservices or Kubernetes infrastructure. Hypershield, I'm going to spend some time on Hypershield as well. Hypershield uses Tetragon in order to protect your applications. We have Hypershield agents, which are available. We have virtual instances of Hypershield as well that you can use in your infrastructure. Or we can run Hypershield even on the smart switches, and I'm going to talk about that as well. Secure Workload is a product that provides micro-segmentation for your workloads. It can be a Windows workload, Linux workloads, or Kubernetes infrastructure as well. Once we are done with gateway and segmentation, I'm going to be focusing on secure access. I'm not going to talk about entire secure access in this particular session. I'll just talk about firewall as a service component of secure access. Then we'll spend some time on explaining what exactly AI defense is. Consider AI defense as a component that provides security for your AI infrastructure. Now let's double click on security cloud control. Security cloud control platform is a cloud-based management platform that was created to bring these security services together. On the other side, you see there are a lot of different products. These products are initially, when we started these products, each product has a different console, different style of managing infrastructure. So as part of security cloud control, we are bringing everything under one UI. So security cloud control provides you centralized dashboard, provides you a way for centralized investigation, and it has a built-in AI assistant where you will type your AI prompt. It will go and talk to various security services and provide you the right answer. It has AI dependency mapping as well, so you have applications running in your infrastructure. Secure Workload will talk to your infrastructure, understand what application is talking to what microservice on what port, and it's going to give you that information as well. This is really important. We have third-party firewall orchestration as well. So there is a new product, Mesh Policy Engine, which is going to be added to the product pretty soon. We are just working with our product management team to work on the licensing for it. But when you will manage your Cisco firewalls, that will be included in the base price for security cloud control. So if you look here, this is the security cloud control, and you can see all the products listed in a single UI. Now, I'll spend 30 seconds on explaining Mesh Policy Engine. Mesh Policy Engine is a product that lets you create intent-based policy. For example, you have your ERP app running in public cloud, and your HR app is in data center. In your data path, you might have 3 or 4 firewalls, one at the edge of your cloud, one at the edge of your data center, maybe an internal firewall or a DMZ firewall in your data center. So some of these firewalls can be Cisco firewalls, and some of these firewalls can be non-Cisco firewalls as well. Today, we support Palo Alto, Fortinet, and we support pushing policies on AMD, Pensando, DPU as well. So when you define your intent that this app should talk to this app, it will automatically look into your topology and create a policy which will be applied to various firewalls. So that's the power of this particular solution. And we have announced Mesh Policy Engine at this Cisco Live. We are going to launch it pretty soon. Now let's switch gears and talk about macro segmentation. Now in macro segmentation, you have a gateway. Gateway will sit between your zones. It can be a web, app, or database tier, and you will place your gateways in that infrastructure. So we have Multicloud Defense Gateway and Multicloud Defense Controller. We also have Cisco Secure Firewall Threat Defense, virtual, and physical. But we are going to focus on virtual today because this is a cloud session, and we are going to be focusing more on public cloud infrastructure. And then we have invested in orchestrating FTDB using Multicloud Defense Controller as well. So before I talk about multi-cloud defense, I would like to spend some time and talk about why multi-cloud defense controller is needed. What are the key challenges when you deploy your firewalls or virtual appliances in the cloud? What are the challenges that you see? So each cloud is different. Workflow is entirely different. So if you want to deploy a virtual instance in AWS, workflow could be entirely different from the workflow of Azure. So that's a big problem. If you are on a journey of multi-cloud networking or multi-cloud deployment, you have to have resources who are expert in all the cloud providers that you use today. Deployment of virtual firewalls can be complex because in some cases, deploying a single firewall is pretty easy. You just go to marketplace listing, deploy it, and you're done. But if you want to enable multiple firewalls, you will have to have a mechanism using which you will auto-scale. And at the same time, you will also see that auto-healing functionality is enabled. In some cases, you will have to play with routing, peering, and gate load balancers as well. This is where Multicloud Defense can help. So Multicloud Defense Controller is a SaaS offer available globally for AWS, Azure, GCP, and OCI. And it is a highly scalable construct. You don't have to worry about scaling of Multicloud Defense Controller. Then we have these gateways. These gateways will run inside of your infrastructure. So you have your AWS VPC. These gateways will run inside your environment. So you don't have to send any traffic to any third party for inspection. Inspection will happen locally. We do support multi-region and multi-AZ architectures. By default, when you deploy these gateways are delivered as platform as a service. The entire lifecycle management of the gateway is handled by controller. For example, if you deploy 5 gateways, one of the gateway goes down, automatically controller will know health status of that gateway and instantiate a new gateway. So that way, auto healing is already there. When you deploy gateways in your account, most important part is how will you route traffic to your gateways. So Multicloud Defense Controller is going to help you with traffic engineering, and we have unified dynamic policies as well. So when you onboard your account, we get information directly from your cloud infrastructure. If there is any change in the IP address, we dynamically update our security policies as well. Now, if we look at Multicloud Defense Gateway, Multicloud Defense Gateway has 2 components again, ingress gateway and egress gateway. And these are some security features which can be enabled on these gateways. So Multicloud Defense Gateway has a single pass architecture, and we have instances available in various sizes, like starting from 2-core, 4-core, 8-core instances. Availability is for AWS, Azure, GCP, and OCI. And these are some use cases where you can deploy your gateways. So ingress use case, you have your application in your environment. You want to protect that application. We have ingress gateway. If you have your application talking to internet, you can use egress gateway for your egress traffic, as well as for your east-west traffic inspection. Multi-cloud networking is another important component of the product. We have taken our VPN code from ASA, embedded that code into our multi-cloud defense gateway so that you can automatically create VPN tunnels. You will define your source environment and your destination environment. Multi-cloud defense controller will go ahead and create VPN tunnels for you. When you deploy multi-cloud defense gateway in your infrastructure, we ask you a simple question. Do you want to deploy it in a distributed environment, or you want to have a centralized security model? And we support both as well, and we call it combined security model. Majority of our customers who are using multi-cloud defense gateway in their infrastructure, they are using centralized security model. If you look at this particular VPC here, this entire VPC is orchestrated by multi-cloud defense controller, and these gateways are deployed here. For example, if I have workloads in my spoke VPC 1, and that workload wants to talk to another workload in spoke VPC 2, traffic will go to these gateways for inspection, and then it'll go to the destination VPC. Similarly, if traffic is outbound traffic, traffic will go to this centralized VPC for inspection. Distributed security model is also supported, where you deploy these gateways next to your application in the same VPC or VNet where your application is. Some part of your network can be protected using distributed model. Some part of your network can be protected using centralized model as well. And we deploy security in minutes using Cisco Multicloud Defense. We just use 3 steps. Step number 1 is onboard your account. You have your AWS account, Azure account, GCP account, or OCI account. We have orchestration. Using that orchestration, you can onboard your infrastructure into multi-cloud defense controller. Once Multicloud Defense controller has the account successfully onboarded, controller will go into your account, look for all the resources which are deployed in your infrastructure, and it will show you that information in a dashboard. Step number 2 is you want to enable visibility. You want to see what's happening in your infrastructure as well. At that point of time, you will enable visibility by sending your DNS query logs, VPC flow logs, or NSG logs to controller. And by utilizing that information, controller will give you detailed information by showing that information in the network topology map. Step number 3 is where you deploy gateways in your environment to protect your workloads. These 2 steps, step 1 and step 2, is entirely free. You can go to security.cisco.com, sign up for Security Cloud Control, enable your multi-cloud defense controller. You can onboard these accounts today and get more information about health of your account. But when you want to deploy gateways, that's where the licensing is going to come in. For multi-cloud defense gateway, we do have an hourly-based licensing where you purchase licenses, like gateway hours, and your gateway hours are counted against the utilization. So once you click on secure your account, we present you with 2 options, centralized or distributed, and based on your requirement, you can select any of the architecture. Now this is example of centralized security model for Amazon Web Services. If you look at this particular architecture on the right side, you will see there are multiple components. You have internet gateway, network load balancer, you have gateway load balancer, you have transit gateway, you have route tables, and this entire architecture is pretty complex. So if you want to deploy this using a CloudFormation template or using Terraform providers, you can do that. But at the same time, imagine if you want to have auto-healing and auto-scaling functionality enabled in your account. That is going to be a nightmare. Yeah.
Those firewalls, so they're PaaS, platform as a service. You don't have any access to the iOS.
Good questions. Question is, for these firewalls, do we have access to the CLI or these firewalls directly? Yes, we do allow access to these devices just for troubleshooting purposes. However, if you want to make any changes to these firewalls, you will be using controller.
Are they active?
I'll talk about that in a bit. It depends upon what kind of traffic is going through the device.
Are they synchronizing the sessions?
I'll talk about that in a couple of minutes. So when you have multi-cloud defense controller will orchestrate entire architecture that you see here on the right side. We can also attach to your existing transit gateway, or we can create a new transit gateway as well. And then we modify configuration on network load balancer, gateway load balancer, and we enable auto-scaling. So at the time of deployment, you will specify your minimum count and maximum count, and that's how we go ahead and ensure that all the instances are deployed. Now, coming back to the question that you had earlier about session synchronization, active-active, I will switch to this particular next slide, and this is where I can answer that question. So you have your instance in this VPC, and this instance would like to talk to internet. In that particular situation, traffic will come to this transit gateway, and from here, we will send it to gateway load balancer of AWS. Why gateway load balancer of AWS? Because we run Geneve protocol natively between our multi-cloud defense gateway and gateway load balancer of AWS. So if you have multiple firewalls, you can send traffic to multiple firewalls, because when your traffic is, or the hashing mechanism will happen on the gateway load balancer, in the Geneve header, it is going to embed an identifier. Using that identifier, your subsequent traffic for that connection will go to that same firewall. Now, There is no state synchronization. Uh, that's not the limitation of the product. We can easily enable that, and we have enabled it in FTD only for AWS, but for multi-cloud defense gateway, there is no session synchronization. But I'll talk about workaround in a bit when I will cover that particular.
The reason I was asking is because your competitors are doing the same design,
Yeah.
but they use Redis for session synchronization, like Multicloud.
Yeah, so I have a slide where we do that with FTD, not with multi-cloud defense gateway. So consider gateway as a different kind of security appliance, but if you are using firewall in your infrastructure like FTD, you might want to have same security policy in the cloud. That's where we will talk about FTD when we'll move to that architecture, but that's a good question. This is another design, sorry. So in this architecture, traffic will land on this network load balancer and inspected on the firewall, then we send it to the other side. For east-west inspection, traffic will come to transit gateway, then gateway load balancer, and then this multi-cloud defense gateway will inspect it and send it to the other side. Now we have similar kind of architecture for Azure as well. In Azure, you have ingress load balancer, which is a public load balancer. You have public IP address on that, and we have egress load balancer, which is internal load balancer. Internal load balancer is little smart because when you enable HA port functionality on that load balancer, it can manage state as well. So imagine if your first packet is received by gateway 1, subsequent traffic will go to the same gateway. And when we use multi-cloud defense controller, we orchestrate security VNet, we orchestrate network load balancer, we orchestrate public load balancer, we can even orchestrate VNet peering between your spoke VPC and your security VNet. And again, autoscale for this architecture is also supported. Sure.
That's a sandwich design. Yeah, two load balancers.
Yeah.
It's called sandwich design.
Sandwich design in a way, but if your traffic is inbound.
Will you pass? Those are pass firewalls now.
Yeah.
Will they have any API calls or any cloud native integration with Azure?
So that's a good question. Do we have API integration with Azure? Yes, not directly from those gateways, but controller has all the API providers. Controller can talk to your infrastructure and do anything you want.
So if zone 1 goes down, how will the firewall know that only that one interface is down?
Because there is a health check between the controller and firewall. Question was, how will Azure know that one firewall is down? There is a proper health check between the controller and gateway.
So they're not in a cluster, they're active all over.
Yes.
So there's no session synchronization.
There is no session synchronization. We will talk about session synchronization when we cover FTDB. Yeah. So this is inbound traffic. If we go to the next one, it is east-west traffic. For east-west traffic, we send traffic to internal load balancer. We then send it to firewall for inspection or multi-cloud defense gateway, and we send it to the other side. This is another architecture where we have Google environment. And in Google, when you have, in GCP, when you have multi-NIC instances, you will have to have one VPC associated to one NIC. This architecture is entirely similar. Only difference is you have a management VPC separate, and then you have data path VPC. But if you look at the orchestration, we can orchestrate security VNet, or security VPC, we can orchestrate internal and external load balancer, we can orchestrate VPC peering, we can enable auto scaling as well.
Can I ask a question?
Yeah, sure.
Session synchronization is not working. This is pass platform?
Oh, this is, so we'll talk about session synchronization when I'll talk about firewall specifically, and I'll answer that question.
The project itself, that means everything is in one enterprise. If I have outside projects from other organizations, how this is going to work there?
Can you repeat that question, please?
If I have outside projects, let's say from partner organization that wants to connect to my presence in cloud, how
Okay, so question is, I have external project which is not part of my account. You need to have trust relationship. You need to have that account or project onboarded into Multicloud Defense Controller as well. So that's there is a workaround as well. We can, I believe I'll stay after this presentation. I'll answer all your pending questions and we'll definitely come back to that. I have a little packed agenda, but we'll definitely do that. This is the inbound flow. Traffic is received on public load balancer, and then it is sent to that instance. For east-west, we use internal load balancer, but again, all these components are orchestrated by controller. So we have talked about centralized security model. Distributed security model for AWS, Azure, GCP, and OCI is also supported. I'm not going to go through the architecture, but that architecture is pretty much simpler. You have one interface of the firewall pointing towards your application, other interface of the firewall pointing towards the load balancer, and then you send out traffic directly from your infrastructure. I'm sorry. Okay. Now, I'll quickly spend some time in explaining what multi-cloud networking is. If you look at multi-cloud networking, this feature was developed because it is really difficult to create VPN tunnels in public cloud. You can use VPN gateway, or you can deploy a firewall and then instantiate your VPN tunnels on those gateways as well. But the idea is you are limited to one tunnel. Here, Multicloud Defense Controller can create cloud-to-cloud connectivity, site-to-cloud connectivity, and we do support distributed and centralized security model. In addition to that, we also support route-based VPN that uses BGP. If one of the tunnel is down, your advertisement will switch to another tunnel so that your traffic can continue flowing. Then we have simplified operation, because everything is done through Multicloud Defense Controller, and then we can use security, advanced security as well. So this is the architecture where you have your VPC1, VPC2 connected to your security VPC using the transit gateway, and this transit gateway has egress gateway here, which is managed by Multicloud Defense Controller. Now, this is your data center where you have your firewall. It could be ASA, FTD, or any third-party firewall as well that can enable VPN that supports route-based VPN. So in this example, Multicloud Defense Controller will orchestrate VPN tunnel on this gateway as well as on the firewall. So Multicloud Defense Controller cannot talk to firewall directly. That communication will happen using APIs between Multicloud Defense Controller and your security cloud control. And that's how we connect back to your infrastructure. If there is a failure of the tunnel, we instantiate another one. This is site-to-cloud VPN. So you have AWS infrastructure, and this is your data center. We can form tunnel directly from there using the controller. Then we have cloud-to-cloud in a centralized security model. So this is your security VNet. This is your security VPC. You can form tunnels directly, and Multicloud Defense Controller will orchestrate tunnels on both of these appliances as well. This is another one, but this is a distributed model, so same configuration mechanism will apply here as well. So controller will talk to this gateway and the other gateway and instantiate tunnels for you. So with this, I will quickly switch to Secure Firewall Threat Defense Virtual. FTDV, for short, FTDV is available for private cloud. All the major hypervisors are supported. It is also supported with public cloud. All the major public cloud providers are supported. We do support Gov Cloud for AWS, Azure, and GCP. We have a smaller instance that starts with FTDV, and we go up to FTDV 100, and we are introducing FTDV Unlimited as well. I'll show that in the upcoming slides. But majority of the features, we have clustering available for firewall. So you can cluster multiple virtual units into a single logical unit. And we have integration with cloud-native services. We have accelerated networking support. If you want to use hardware acceleration, there is a different type of instance that you can use, and you can take advantage of accelerated networking. We support pay-as-you-go model. We support bring your own license model as well. We have dynamic policy as well. So there is a component known as Cisco Secure Dynamic Attribute Connector, which will get information about attributes, which will get information about name tags from various places, and you can consume that information in your security policy. We do have quick starts. We do have infrastructure as code. So anything that you see in the UI of firewall management, we have a provider for that, and then you can use Terraform provider. Yeah, sure.
The cloud controller can actually integrate with network security groups from each cloud provider and actually have like a one central pane of glass to push policy.
So question is, can Multicloud Defense controller configure policies natively on security group and network security group? Answer to that question is no, but we do have a product which I will cover, which is Secure Workload. Secure Workload can do that natively, and I'll cover that as well. Then we do support snapshots. And why snapshot is needed? Because FTDV is a little heavy appliance. If you want to use it in autoscale, it will take longer time to instantiate a new instance. So when we enable autoscaling for FTDV, we automatically create a snapshot, and that snapshot is used for creating another instances as well. Now for management of FTDV, we have Firewall Management Center. Firewall Management Center can be a hardware appliance or a virtual appliance. It can be in your data center, or it can be provisioned in cloud as well. Or you have the security cloud control option as well. There is a component which is known as Security Cloud Control Firewall Management. It is required if you want to have cloud management for firewalls. There is another version of firewall that we are introducing, which is unlimited. So you can look at various hardware components that you can add. You can go up to 64 CPUs. You can go up to 128 gig of RAM, and there is no software limiter applied on FTDV Unlimited. I don't have performance numbers yet because our engineering team, our testing team is working on that, but it would be somewhere around 60 gig throughput using this Unlimited. Don't quote me on that number. We are just expecting right numbers from our engineering team so that we will publish it once this product is available. We have support for VMware, Nutanix, OpenStack, KVM, and Hyper-V. Now, when you deploy firewalls in AWS, FTDV, you can deploy it in routed mode. When you deploy these firewalls in routed mode, you can put it between interfaces and enable stateful firewalling, VPN, application visibility control, IPS, IDS, URL filtering, and malware protection. On your appliances, you can manage it using FMC or cloud-delivered FMC, and we support both options, BYOL and pay-as-you-go. If you want to have multiple firewalls in your environment, you can put it behind internet-facing load balancer. Only caveat with this particular architecture is if you have your inbound traffic will hit your external load balancer, and external load balancer will then send it to firewall. But on firewall, you have to enable destination NAT as well as source NAT. Because when this traffic is received on these instances should know which firewall initially processed this traffic. That's the reason we need source NAT there. But we do have alternative architecture where source NAT is not needed, and I'm going to cover that as well. Autoscale is supported for firewall in AWS, Azure, GCP. You can place these firewalls behind a load balancer. It is not a load balancer sandwich model, but similar to that. On the other side, you will have one public load balancer. If traffic is ingress, if traffic is egress, you have internal load balancer for doing that. We fully support multi-AZ architecture. If you look at this multi-AZ architecture, you can deploy firewall in AZ1, firewalls in AZ2 as well, and then connect your spoke VPCs using transit gateway. Now, if you have multi-AZ architecture, you need to ensure that you enable appliance mode attachment on your transit gateway. The appliance mode attachment is going to enable some intelligence on the transit gateway. The moment you enable appliance mode, if your traffic is processed by firewall in availability zone 1, return traffic will always go to the same firewall. Gateway load balancer architecture is similar, but we run Geneve between gateway load balancer and these firewalls natively. And when we run these firewalls, any traffic received on the firewall will be sent to gateway load balancer. Any subsequent traffic based on the embedded identifier in the Geneve header, subsequent traffic will go to the same firewall. Now I will talk about clustering. In clustering, we have multiple firewalls here in this design, and we are going to create a cluster of these firewalls. Once you create a cluster, one of the firewall that receives the initial packet becomes owner of the connection. And on the reply, it is not necessary that your reply packet will come back to the same firewall. So the other firewall that receives the traffic becomes the forwarder, and it sends your traffic back to the owner of the connection. Then owner updates that state into director as well. In case owner dies, director can pick your session midway as well. That's the complete flow of clustering. But if you look at this architecture, this is a simplified version of the previous architecture that I showed you, because here in this slide, I'm just showing you one availability zone, but you can do it in multiple availability zones as well. You have this gateway load balancer. This is your cluster. Traffic is initiated from outside. Traffic will first land on the internet gateway. From there, it will go to your gateway load balancer endpoint. Gateway load balancer endpoint will send it to gateway load balancer, and then we receive that traffic on firewall, and then we forward it to the instance. And east-west traffic is similar. Same traffic flow. Gateway load balancer is doing all the magic. And on gateway load balancer, there is a feature known as rebalance. If you enable that feature, if one of the firewall in the cluster dies, and if your initial packet was handled by that firewall, if rebalance is enabled, you can then resume your connection, because we do share states in this architecture. We have east-west protection as well for the clustering environment. This is your data center. Traffic goes to your transit gateway, and from transit gateway, we send it to security VPC, and then we send it to the destination machine. Now, I want to spend a few minutes explaining our new offer. On this offer, we worked closely with Azure, Microsoft Azure. And this is an offer where we have Cisco Secure Firewall as an NVA, Network Virtual Appliance, in your vWAN hub. Yeah, sure.
The previous page, cluster, it's the one availability zone or across multiple?
The question is, in the previous slide, when I talked about the architecture, it was just one availability zone or multiple availability zone. Answer is, yes, we do support multiple availability zones as well. Okay? Yes. Now, if you look at the virtual WAN architecture, this is your vWAN, and this is your hub-to-hub connection. So you have one hub in US East, other hub is in central US. We can send traffic across these hubs as well, and we can enable these use cases. East-west, VNet to VNet, branch to branch, branch to VNet, VNet to branch, branch to internet, and VNet to internet. And we support both management consoles here as well. So you can deploy these firewalls with multiple instances in virtual WAN as well. Now, when I started my presentation, I talked about multi-cloud defense controller orchestrating FTDV. So why do we need multi-cloud defense controller in this particular situation? One, multi-cloud defense controller will orchestrate deployment of your firewall, will orchestrate deployment of your route tables, it will orchestrate deployment of your security VPC, and you will just specify how many virtual instances I need, what kind of VPC I want to protect or VNet I want to protect. The entire traffic engineering orchestration is done by multi-cloud defense controller. Now, in this architecture, we support bring your own license, where you will have a smart account. You will add your licenses to your smart account, and firewalls will consume those licenses as they scale up, return those licenses back to your account when firewalls will scale down. We have recently introduced Premier license as well. Premier license is also known as SaaS license. If you go to Azure or AWS, while deploying these firewalls, you will see SaaS option there as well. Difference between SaaS and bring your own license is, with bring your own license, you buy base license, which gives you functionality for firewalling, application visibility and control. And then on top of that, you buy term licenses like threat, which will give you IPS/IDS capability, malware, or content license. But with SaaS license, you get fully featured virtual instance for your cloud environment. Now, when you use multi-cloud defense controller to deploy your firewalls, we deploy one or more firewalls along with the required load balancer. We configure all necessary route tables. We also make sure that your workflow for AWS, Azure is entirely same. And once your firewalls are deployed, firewalls are automatically registered into your management console. It can be your firewall management console, or it can be security cloud control as well. And we also enable licenses accordingly. We do the license management, and we do bootstrapping of these instances as well. We configure device group, platform settings, NAT, routing, interfaces, and everything. You will just define how many firewalls I need, and we will do all the rest of the configuration directly from the controller. This is the architecture similar to what I have showed you in the earlier slides, but the difference is, if you look at this, these virtual instances, these are not multi-cloud defense gateway. These virtual instances are your virtual firewalls, FTDs. And the moment these FTDs are deployed, these FTDs are automatically added to the load balancer. It is also added to your gateways, and we will register these into your management platform as well. And we take care of your traffic engineering as well. So you don't have to go back to your spoke VPCs and change any route. We do that automatically. Similar architecture is for Azure as well. And again, just to keep this slide simple, I'm using single availability zone architecture. But any architecture that I showed you in today's session, we do support multi-AZ and multi-region architecture for that as well. This is the slide on auto-scaling. And I wanted to add this slide just to show you what performance metrics we monitor in order to scale up. Let's say you start with 2 firewalls, and you define CPU and memory as as the parameters for scaling up. The moment you hit the threshold, we go ahead and instantiate new firewall. There is no CloudFormation template needed. There is no additional script, Lambda functions, Azure functions needed in order to enable this. And whenever we add new device, we add it to the required load balancers as well. We enable auto healing, health status monitoring, and we ensure that there is no manual configuration needed in order to bring these instances up. With this, I will go to a quick demo where I'll show you the architecture where you have spoke VPC1, spoke VPC2. We will orchestrate this portion that is in the blue box. And once these firewalls are up, we will route traffic to internet and see how that's going to work. This is the Multicloud Defense controller console. If we go to infrastructure, we go to gateways, we click on add gateway. On this page, we define our account in which we want to deploy this infrastructure or this firewall. Then we define type of gateway that we want to install. You can see that Multicloud Defense gateway is there, FTDV is there. Then you define name for your firewall infrastructure or group, actually. So if you have multiple firewalls, all those firewalls will be added in the same group. And then you define, OK, I want to enable east-west and egress use cases. I have this access policy, which is already there on my management console. I want to use that policy. I define SaaS license or BYOL license. Then I define, OK, I want to use FTDV 50 with base license. I could have gone with SaaS license as well. Then I define my region. I define my availability zone. I specify key. This key pair is required if you want to gain access to the firewall directly. And then you specify your management security group, data path security group. We can leave these as is, and then we specify all the information about availability zones. On the next screen, once we deploy, it will show you that these many components are going to be deployed, and this is your existing limit. And when you click on finish, we go ahead and talk to your cloud account and deploy these instances there. And this is where I'm just looking at my infrastructure to see if these instances are getting enabled or not. So once I see my group is active, I can go back to my cloud security cloud control. I can see all these firewalls are there. There is a default security policy, which is already there. The bootstrap configuration for all the interfaces is done automatically. And then we go to devices. Now, in devices, you can see that device is already there. This is my app machine where I have initiated traffic from that machine, which is there in the VPC1. I'm going to initiate traffic to google.com. The moment I initiate that traffic, it goes to the security VPC for inspection, for firewall for inspection. If traffic is allowed, we then allow that traffic. And then I'm going to another portal as well. We are able to do this automatically from the controller because controller knows where to route traffic, how to route traffic, and configure those firewalls for you. You can enable auto-scaling as well. So auto-scaling is one of the options there. With this, I will switch to segmentation. In segmentation, I will be covering Isovalent Enterprise. I will talk about Hypershield. I will talk about Secure Workload as well. But I want to spend some time and talk about these two components. These two components are part of security cloud control. Isovalent Enterprise is not part of security cloud control. We are working with the engineering team to enable that. And we don't have any committed timeline, but that's going to be enabled. We are working with our team on making it a priority. So now, anybody using Isovalent in their infrastructure? Okay, just one hand, okay. I'll just specify what exactly this Isovalent is and how we use it. In April of 2024, Cisco acquired Isovalent. So Isovalent is considered as the de facto standard for networking security in your Kubernetes infrastructure. So Isovalent is the leading company which is behind Tetragon and eBPF and Cilium. Now, all these three products are open source projects, but we do offer enterprise distribution of Cilium and Tetragon. And I'll talk about these components in the upcoming slide. So again, Cilium is the de facto standard for Kubernetes infrastructure. Then we have Tetragon. Tetragon is heavily used in Cisco Hypershield. This product brings in capability of enforcing security, distributed security on endpoints. I have added this information here just to show you history of Isovalent, not Isovalent, but the cloud native services. So 2014 is when first Kubernetes commit happened. 2014 is when eBPF was created. Cilium was created in December of 2015. Isovalent was founded in 2017. And then, if you look at this timeline, this is the GKE, Google Kubernetes Engine, their managed Kubernetes platform. They selected Cilium as one of their networking component. Same thing happened with Amazon as well. Then we saw a similar thing at Azure as well. So all the managed Kubernetes environments, they are using Cilium. Cilium is really powerful in enabling networking in your microservices infrastructure. So now let's look at the Kubernetes networking. So in Kubernetes networking, pod consists of one or more containers. One pod can represent your entire application, or your application can have multiple pods as well. Pods are deployed on nodes. These nodes can be your bare metal nodes or bare metal servers, or these can be on the virtual instances as well, or like EC2 instance or a VM in Azure. Now, collection of nodes, or the collection of nodes is a Kubernetes cluster. If you want to enable communication between pods, you need a plugin known as CNI, or Container Networking Interface. There are multiple vendors available in the market. They provide CNI plugin, but the Cilium CNI is something that we are going to cover today, because that's the one which is being provided as part of the Isovalent infrastructure. Now we'll talk a little bit about eBPF. So when you deploy any instance or a microservices architecture or any kind of instance, you have a user space, you have kernel as well, right? Reprogramming kernel can be entirely different. It can take ages to submit your change. It will go through the committee approval, and it might not happen. So this is where eBPF can help. eBPF can help you making your kernel programmable. When I say programmable, it can dynamically create programs that can run inside of the kernel that can be triggered using any sort of events. And this is a really powerful tool, high performance, low overhead infrastructure tool that provides you capabilities like networking, scalable networking, observability, and security. Now, when you have applications running in pod, your node can have multiple pods, but one node have a kernel, and then that kernel can be programmed using eBPF, and you can enforce policy in a distributed architecture. So if you have few applications running on one node and some part of the application running on the other node, you can have distributed policies across your environment. Now, in container environment, IP addresses can change anytime. Pods can be created or destroyed anytime. So there is no relevance of an IP address. That's the reason whenever you will see network policy in your cloud native infrastructure, identifier is not your IP address, it is label. So in this example, what we have here on this side is a sample network policy. So if you look at default Kubernetes network policy, it is L3, L4 policy only. But when you select Cilium network policy, it gives you more support for more features like L3, L4 policy. You have L7 policy. You can do FQDN-based policies as well. But when you define your source and your destination, you define your label instead of IP address. Now, here is the example for a layer 3 policy if you're using labels. So here you can see we have backend, front-end system talking to backend system, and we are allowing entire IP from front-end to backend. This is an example of L4 policy where I am defining traffic from front-end to backend, but at this point of time, I'm using port information as well. So that's how we define L4 policy. For L7 policy, you are defining additional parameter here, which is you're defining get. So you are saying this machine can, or this service can talk to backend service, but only on HTTPS, but only get operation is allowed. Similarly, if I look at DNS-aware policy, so in this example, I am writing a policy for anything which has mydomain.io in it. So traffic will go to this domain. Before that, you will send a DNS query, and once your reply is received, your traffic is allowed or dropped based on the policy that you have created. So when you write a policy, you define who the policy applies to. In this particular situation, you can see this is the label that I'm going to match. Then I define whether this policy is going to be an egress policy or ingress policy, and I define that information here. Then the next portion of the policy is my destination, and then I define my ports as well. By default, out of the box, Cilium can also enable encryption between microservices. So you have front-end service here and the back-end service here. You can use Cilium to enable encryption as well. With this, I will switch to Hypershield. So Hypershield is one of the products that heavily uses Tetragon. And it is part of security cloud control. We do apply a single global policy. There is no concept of having a dedicated policy for a device. We create one global policy, and those policies are independent of order. So whenever traffic is initiated or any process is initiated, we first check all the deny rules, and then we switch to permit rules. And this particular firewall is supported for Kubernetes infrastructure. We have support for public and private cloud. We have support for on-premise infrastructure as well. And then AI ML is embedded natively into the product. We can have policies based on the kernel level details, and these policies are used for micro-segmentation. On the enforcement side, we have agent for Linux machine, for Kubernetes, and we have a virtual appliance as well. Let me switch to this particular slide to give you more information on Tesseract Security Agent, or TSA for short. This agent can run on your end system, or you can have network-based enforcer as well. I'll come back to network-based enforcer in a bit, but if you look at this architecture here, this is your Kubernetes infrastructure. You can run your agent inside your Kubernetes cluster and create policies, create enforcement based on your kernel level information. On the end system enforcer, we can deploy it on Linux as well. Windows is currently not supported because everything that you see here is eBPF based. And eBPF is not currently available for Windows. Not we, but the entire industry is working with Microsoft to enable that functionality on Windows. Once that is available, we are going to enable that on our product as well. Here it is a bare metal server where you can use the agent. On the hypervisor, you can run agent directly into your VM as well. And then we also have network-based enforcers. When I talk about network-based enforcers, consider this as a virtual appliance running inside of your environment. So it's similar to ASAV or FTDV, but instead of firewall policies, you are writing policies based on kernel level details. And you have inbound interface and outbound interface as well here.
Is that similar to like NSX?
Yes. Now, Hypershield can also be deployed on DPU. So
is the network-based enforcer like the smart switch?
yes. Yes, the smart switch. Oh, can you repeat that question? I'm sorry, I didn't.
So is the network-based enforcer that you referenced there, is that referring to a smart switch, or is there something else besides the smart switch that is a network-based enforcer?
So here, this portion that you see here is the smart switch. If you have zone-based firewalling, the previous slide was not the smart switch. It was just the virtual instance running on any of your host, right? But here, if you look at this one, this is your smart switch, and you're running this on your smart switch as well. So we do have two options. If you are using a switch, you can deploy it on a DPU on that switch. If you have a smart switch, we give you that capability on that smart switch natively. If I go back to the previous slide, this is just the virtual instance running anywhere in your environment. Like you have a VM in your environment, you can run this there as well. It's not a smart switch. Smart switch model is this one here. Sure. Now with this, I will quickly switch to secure workload use cases. Secure workload was previously known as tetration. The biggest use case for secure workload is micro-segmentation. The other use cases are around vulnerability management and behavioral detection as well. So when you deploy secure workload in your infrastructure, secure workload gets visibility of your environment. And using that visibility, it will discover your applications. It will give you application dependency map. It will also give you information about processes running on your workloads. For example, if you have workload agent running on your workload, it can actually see if there is any change in the behavior of the system. For example, if there is escalation privileges on any of the workload, it's going to give you that information, and it will show that information in the dashboard. Recently, we have enabled, when I say recently, it's like 1 year ago, we have enabled vulnerability detection. So there is a product known as Kenna, Cisco Vulnerability Management. We have enabled integration with CVM, or Cisco Vulnerability Management. Cisco Vulnerability Management provides us information about any vulnerability running in your infrastructure. Once you have that visibility, you can then take actions. When you take actions, you can talk to firewall and virtually patch it, because security policy that you create on secure workload is L3, L4 policy. So we have a built-in integration between secure workload and secure firewall. So you can actually recommend a policy, send it to firewall, firewall can write that into, yeah.
Is that vulnerability detection and Canna integration free? Or whatever Canna can do, secure workload can do as far as vulnerability detection?
Yeah, good question.
Like a subset?
Yeah, so question is the vulnerability Canna integration free? So you don't pay anything extra for getting that intelligence. We do that natively into the product, and pricing is built into the product already. There is no separate license to enable it. Once you get that information, you can use it to take an action. Now, in this example, this is your infrastructure, and in this infrastructure, we have host connecting back to your application, and this is a zero trust architecture. So first step that we are going to do in this architecture is we are going to enable visibility. When I say visibility, we are going to share flow logs so that secure workload can actually look at the information and see what's happening in your infrastructure. It will also, we can also gather more information, discovery context from these resources as well. One fine example I can give you is identity services engine. We can get information about users from AWS, Azure, GCP. We can get information about your tags. And if you use info blocks for IP management, we can get more details from there as well. Once we have this information, we are going to discover a policy, analyze it. Based on the information we are getting, we are going to recommend a policy. Once we recommend a policy, that policy is then sent down to these policy enforcement points. And if you look at this place here, this is your VM, this is your Kubernetes infrastructure, and it doesn't matter where these are deployed. You can enforce these policies in the cloud or in your data center. And we do have integration with cloud service provider. You can manage security policies in your cloud infrastructure as well. And you can have enforcement points directly here. And I was talking about NSG and other constructs like security group or network security group that can be enabled as well. And third piece is integration between secure workload and secure firewall. So secure workload is going to share that information with Firewall Management Center. Firewall Management Center will receive the policy recommendation from secure workload, and then Firewall Management Center will push down those policies to your firewalls. There is a recent integration on DPU as well. We were working closely with NVIDIA, and we have enabled integration with NVIDIA DPU as well. So if there is a policy recommendation, we can add those policies directly on to those NVIDIA DPUs as well. Now, I'll talk about other services as well. Secure Access. Secure Access is our solution where you get features like firewall as a service, security web gateway, cloud access security broker, and zero trust network access. So using all these products, you can provide security to your remote user, and this is a use case where you have user to app kind of traffic flow. Now, in this example, okay. I'm sorry, I think something happened to this particular slide, but just imagine there is a laptop here. Try to connect to these applications. So you have protection for internet apps. So that protection is provided by Umbrella. Then we have any protection for traffic going towards SaaS applications, we do it by CASB. We have option for ZTNA going back to your private interfaces, and then you have VPN connection for more of a traditional VPN connectivity. The idea why I have added Firewall as a service to this particular session is because I wanted to talk about how we connect our secure branches to internet or secure branches back to public cloud. So in this example, you have your branch user talking to internet. That traffic will go through secure access and then to internet. You can have SD-WAN connectivity from your branch to your public cloud as well. So that's the reason I included this here. With this, I want to switch to AI defense. Consider AI defense as security for your AI infrastructure. AI is one of the hottest topics at the moment, and majority of our customers are building their own AI infrastructure. But at the same time, when you have too much data using which your AI model is learning, imagine if something happens to that particular data and it is sent out of your infrastructure, that can be really dangerous for image of any enterprise. So we do provide a solution where we discover, detect, and provide protection. So if you look at this design here, I have my Gen AI app here, and then I have my AI model here. In addition to that, I have Multicloud Defense Controller, and Multicloud Defense Controller has information about this account because we have onboarded this environment into Multicloud Defense Controller as well. Now here in this example, and I'm sorry for this graphics, I don't know how, when we converted this to a PPD which can run on Windows, it messed up, but yeah. Is there a question?
Will you provide an updated one in the WebEx? An updated presentation that'll be fixed?
Yeah, sure, I will do that. Yeah. So in this example, if I have this Gen AI app talking to this model, I can insert Multicloud Defense can find out this infrastructure, detect, and you can specify, okay, I want to ensure that my AI model is secured from any of the threats. Imagine if your Gen AI app is compromised, a hacker or the attacker can get into this and exfiltrate some data. So in this example, Multicloud Defense Controller will instantiate a spoke VPC. Inside of that, it will deploy Multicloud Defense Gateway, connect back to your Gen AI app infrastructure, and make sure that firewalls are in place. Now with this, I will talk about securing your hybrid environment. If you look at this architecture again, this is where we started our journey. We talked about applications, we talked about where these applications are deployed, and we talked about managed Kubernetes, we talked about unmanaged Kubernetes. We talked about all the different types of applications that we have. So now, if you look at Hypershield, this Hypershield can be deployed on hosts, switches, DPUs in your infrastructure. Then we have Cilium, CNI, can be deployed on unmanaged, and on the managed Kubernetes infrastructure, it is already a selected model by hyperscalers, but we generally don't manage those. Those are managed and operated by hyperscalers. But for managed Kubernetes, you can still use your secure workload for protecting your infrastructure. Then we have secure workload. Secure workload can sit directly on these managed Kubernetes engines, your workloads, and in some cases where you have DPUs, you can put your secure workload on those NVIDIA DPUs as well. Now, if you look at gateway side of the house, in gateways, you can see I can create virtual appliances in public cloud. I can deploy virtual appliances in my co-location facility, in branches, in campus, and in my data center as well. Multi-cloud defense gateway is specifically for cloud environment. When you want to orchestrate your firewalls, your multi-cloud defense gateway, you can place these in your public cloud infrastructure. So AI defense is applicable where you have your Gen AI infrastructure and you want to secure that infrastructure. We can insert multi-cloud defense gateway, and that is done by using a product known as AI Defense, because it has intelligence about all the AI models which are available. So it can get that information, relay that information to multi-cloud defense controller, then go back to your infrastructure and deploy gateways in your environment. SD-WAN or secure branch can be enabled on firewalls, routers at various places. You can run SD-WAN directly in public cloud, in your co-location facility, branches, campus, and your data center as well. Remote users, this is a remote user which can connect back to your infrastructure. This remote user can connect back to your infrastructure using secure access, or you can deploy physical firewall in your data center or virtual instances of your firewalls and terminate VPNs directly on your firewalls. Then we have ICE for posture, identity, and SGT as well. So imagine you have requirement of creating policies based on security group tags. You can do that. ICE can help you with getting the SGT to IP mapping, and we share that information with a component which is not listed on this particular slide, and that component is Cisco Secure Dynamic Attribute Connector. Once CSDAG gets information about your SGTs, it's going to create SGT and IP-based mapping, and then we push that information to Firewall Management Center, create policies, and then those policies are applied to your virtual firewalls. So now, we talked about a lot of products, and I just want to spend some time on explaining how you can buy hybrid mesh firewall or this particular complete solution that we were talking about. So there is something known as Cloud Protection Suite, and there are different tiers available, but at this point of time, we have Essential tier. In Essential tier, we have Essential Segmentation, focused on micro-segmentation. When you buy segmentation, you get options to deploy any of these products. You can deploy all, or just one, or any two, but we give you option of using any of the product. You must have noticed there are some overlaps in Hypershield and Isovalent. Based on your requirement and use case, you can migrate your licenses from one to other, or from Secure Workload to Isovalent, and then you can play with your license environment. AI assistance is by default included for Essential Gateway and Essential Segmentation as well. When you buy Essential Gateway, you get your FTD V30 with base license and 90 days unlimited logging. We give you access to security cloud control for management of your firewall, and we also provide you multi-cloud defense gateway premier license. When I talk about premier license of multi-cloud defense gateway includes your ingress gateway, egress gateway, and multi-cloud networking piece as well. Multi-cloud networking piece is not available in the tier which is known as Advantage tier, but in Cloud Protection Suite, by default, we add Premier tier as well, so you have fully orchestrated IPsec tunnel in your environments as well. At this point of time, I think I'll switch to this slide I have added some resources for your reference, and I'm going to create another PDF version, paste it in the space, so that there were like few slides where we had some issues with graphics. I will try to resolve that. And we take our surveys pretty seriously. So if you can go back and look at the surveys, feel free to add some information about what you liked about this session, what you didn't like, and we will come back to the next Cisco Live with improvements, and we'll try to cover more use cases. And then you can continue a journey of learning by visiting World of Solution, looking at the hybrid mesh firewall, cloud security control, and mesh policy engine at World of Solution. And here is my contact information again. And I think at this point of time, we are at the end of the session. Once again, I want to thank you for your time and for joining me on this journey. We still have 4 minutes. If there is any pending question, I can take live. If there is any question which is unanswered in the space, I can take that question live as well.